Unraveling infinity concept and misconceptions. Infinity. The very word evokes a sense of awe and mystery. It represents the boundless, the limitless, the eternal. But what is infinity really? Is it a number, a place, or simply an idea? Often infinity is misconstrued as a quantifiable entity, a destination we could reach. Some imagine it as a vast, unending expanse, a realm beyond the farthest stars. However, infinity is not a thing in the way we typically understand things. Instead, infinity is a concept, a mathematical abstraction representing something without limit or end. It's the idea of something continuing forever, always having more, never reaching a final point. Imagine counting numbers, 1, 2, 3, and so on. You can keep adding 1 infinitely without ever reaching an end. That's the essence of infinity, the potential for endless continuation, not a concrete endpoint. Infinity, a substance. Unpacking the paradox. Can infinity be a separate, tangible substance? Can we have an infinite amount of something in the real world? The answer, simply put, is no. The concept of a separate, tangible infinity contradicts the very nature of our physical reality. Everything we observe in the universe, from the smallest atom to the largest galaxy, is finite. Even the vast expanse of the cosmos, while seemingly endless, is believed to be finite in size. Imagine holding infinity in your hand. What would it look like? How much would it weigh? These questions highlight the absurdity of treating infinity as a physical substance. It defies our understanding of physical properties and the laws of physics. Infinity cannot be contained, measured, or observed in the same way as the finite elements of our universe. It's a concept that exists outside the realm of physical manifestation. The never-ending division, infinity and the divisibility paradox. The concept of infinity is closely tied to the divisibility paradox. This paradox explores the idea that any finite quantity can theoretically be divided infinitely. Take a piece of paper, for example. You can fold it in half, then in half again and again and again. Theoretically, you can keep dividing this paper infinitely, even though the pieces become infinitesimally small. This thought experiment illustrates a fundamental aspect of infinity. It's not about reaching an endpoint, but about the potential for endless continuation. We can conceive of dividing something forever, even if we cannot physically do so. The divisibility paradox highlights how infinity challenges our intuitive understanding of the world. It forces us to confront the limitations of our perception and embrace the abstract nature of certain mathematical concepts. Great minds disagree. Philosophical arguments against actual infinity. The concept of infinity has puzzled philosophers for centuries. Many, like Aristotle, argued vehemently against the existence of actual infinity. Aristotle distinguished between potential infinity and actual infinity. He accepted the idea of potential infinity, such as the endless progression of numbers. However, he rejected the idea of actual infinity, arguing that it leads to logical contradictions. For instance, if there were an actually infinite number of things, wouldn't that mean that all things are equally infinite, making the concept of infinity meaningless? Such paradoxes led Aristotle and many others to conclude that infinity is a concept of the mind, a tool for understanding potential, not a description of actual reality. Section 5. Infinity in the real world, physical and mathematical impossibilities. When we look for evidence of infinity in the real world, both physics and mathematics present insurmountable roadblocks. Physically, everything we observe has boundaries and limitations. Even the universe itself, though vast, is believed to be finite. Black holes, often touted as points of infinite density, are better understood as regions where our current understanding of physics breaks down. Mathematically, infinity serves as a useful concept but not a tangible number. We can't perform standard arithmetic operations with infinity in the same way we do with finite numbers. Adding or subtracting from infinity doesn't change its nature, leading to mathematical inconsistencies. For example, if you add 1 to infinity, you still have infinity. This defies the basic principles of addition and highlights the unique nature of infinity as a mathematical concept distinct from a numerical value. Section 6. The illusion of endlessness. Zeno's paradoxes and the nature of infinity. The ancient Greek philosopher Zeno proposed a series of paradoxes that further illustrate the counterintuitive nature of infinity. One such paradox, the dichotomy paradox, imagines a runner trying to reach a fixed point. To reach the destination, the runner must first cover half the distance, then half of the remaining distance, and so on infinitely. Zeno argued that because the runner always has to cover another half, they can never actually reach the endpoint. While seemingly absurd, Zeno's paradoxes highlight the disconnect between our intuitive understanding of motion and the concept of infinite divisibility. They underscore the difference between the theoretical possibility of infinite division and the practical limitations of reality. In the real world, the runner would eventually reach their destination. Zeno's paradox serves as a thought experiment, illustrating the complexities of applying abstract concepts like infinity to concrete situations. Section 7. Beyond the finite, the practical applications of an abstract concept. Even though infinity is not a tangible entity, it plays a crucial role in various fields. In mathematics, it forms the basis of calculus, allowing us to understand concepts like continuity and limits. Engineers and physicists utilize infinity in calculations and models, even though they deal with finite quantities in the real world. Infinity serves as a theoretical limit, a way to approach and understand the behavior of systems under extreme conditions. The concept of infinity also fuels our imaginations, inspiring works of art, literature, and philosophy. It allows us to ponder the boundless possibilities of the universe and grapple with existential questions about the nature of existence. From the vastness of space to the intricacies of mathematics, the concept of infinity, while abstract, has profound implications for our understanding of the world around us. Section 8. Conclusion: infinity, a concept, not a reality. So can infinity be a thing? The evidence overwhelmingly points to no. Infinity is not a physical substance, a destination we can reach, or a number we can quantify. Instead, infinity stands as a powerful concept, a testament to the human mind's ability to conceive of limitless potential. It's a tool for exploration, a source of wonder, and a reminder of the vastness and mystery that lie beyond the boundaries of our finite understanding. While infinity may not exist in a tangible form, its influence on our understanding of mathematics, physics, and the very nature of existence is undeniable. It serves as a potent reminder that some concepts, while abstract, hold the power to reshape our perception of the cosmos and our place within it.